Hello. Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest test preparation and learning platform. Students, I'm really very sorry. I would like to apologize for you for this delay because I was on another session and that was an amazing session. I would recommend that you go and watch the session after this video. We have discussed, within few minutes how to prepare for, your JEE in 30 days and also score 90 percentile or 99 percentile and above. And guys, this is JEE English. This is the channel where we have top-notch faculty on this channel who are taking you from the basics until the depth. And we have previously cleared IITs and other tough exams, and we know what you need to do to clear these exams and also understand every bits and pieces of the topics. And this is an amazing channel. This is the nation's first channel that is delivering content exclusively in English. And we, Unacademy, did this because we thought language should not be a barrier to your learning. That was the entire motto. And today we will understand something amazing. That's the Wheatstone Bridge, a type of a bridge circuit. What do I mean by a type of a bridge circuit? We'll get into it. It's a very interesting topic. It has a lot of applications in real life. You're in fact using this Wheatstone Bridge every day, but probably you haven't realized it, because it is something amazing that we are going to do today. And this amazing thing is Wheatstone Bridge. And students, I would like to again introduce myself. I am Murlidharan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top ranking electrical engineering university in US. And I'm an IITian and an electrical engineer. I have 4+ years of experience preparing students for JEE and other competitive exams. I have filed 22+ patent applications in India, US and Canada, and they are also related to electrical engineering. And guys, today we are going to explore a very interesting concept. Stay along. It's going to be a very short session and you're going to enjoy it. Do also have a look at that video and do enjoy. And I'm really sorry for those for whom I wasn't able to reply to your queries on the last video, because I didn't expect it to get extended beyond 20 minutes. It got extended a little bit, but we will work around that. If any queries, do drop a message on this video session and we will clear that. And students, also you want to maybe download the Telegram app and get onto a Telegram channel, that is JEE_English. It's a very interesting channel where we have all the timely updates on our schedule, on our videos, on our special classes, etc. You want to download this Telegram app first and then type in JEE_English and you'll get onto a channel. Else, the best thing you can do is you can just click onto this link and you'll be redirected over there and you can get onto a channel and you'll get all the timely updates. It's a one-stop hassle-free solution to get all the timely updates about JEE English, and our faculties are continuously working for you and delivering your lectures on time. That being said, today we discussed how to score 90 percentile and above in your JEE Physics. Tomorrow we are going to discuss how to score 99 percentile and above in your JEE Physics. That's going to be awesome and amazing. Do understand that there is a difference between scoring 99 percentile and above in JEE Physics, because you are going to prepare not just for 30 days but a longer journey. It's going to be a longer journey. These 2 hours we are going to exclusively talk about all those data and all those necessary actions and all those techniques that you need to do to score 99 percentile and above. Do not miss this class. It's going to be a very interesting class, and not only that, you are going to love the class just like how you love every day. And students, it's going to have more information than ever and you will enjoy it. And that being said, I would also recommend that you download Unacademy learning app, because you want to attend such special live classes. Not only that, it's going to be amazing if you download this Unacademy learning app, because we have so many special classes that is going on every now and then by top-notch educators, which are totally free of cost, just like this JEE English channel. And you may want to download the Unacademy learning app also to get some timely updates. And guys, if you're preparing for test and if you're looking for something interesting, we have our JEE subscription platform which delivers amazing content. We have 6,000+ lectures and 6,000+ content for your JEE preparation, and you can dedicatedly choose your goal as IIT JEE. I would highly recommend that you choose this program, attend these tests regularly and excel in them. I would really hope that students attending my classes attend these tests and excel in everything that they do. And in physics, you have to love it, you will excel in it, you don't have to worry about it. And it hardly costs 1500 per month if you're on a 2-year long journey, that is you're in 9th, 10th or 11th class. Or if you're a long term or dropout, it's hardly going to cost you 2500 per month for next 12 months. And that being said, if you're looking for something for your 1 month preparation, or if you're looking for something where you can prepare during this lockdown, we have 1 and 3 month subscription with 6000 plus materials, and also famous JEE preparation, like legends, or you can call them celebrities like DC Pandey on the platform, who are delivering lectures and providing the content. And it's very important to understand people like this will help you excel in your exam. And you can apply Murli live coupon to get a 10% instant discount on any of these programs. And do share this coupon code, and do share this video, and do like the video, click on that subscribe button, click on that bell notification to get timely updates. And before we get into the topic, some more motivation. Dream is not what you see in your sleep, but that one that does not let you sleep. It's said by Dr. Sir APJ Abdul Kalam, and it is always true, be it if you heard it in the last session, or be it if you heard it in this session. Hello Hariharan, hello Ambar Agarwal, I hope you are all doing well. And we'll get into something really interesting today. That's going to be Wheatstone Bridge, guys. If you're a little late, that's fine, you're going to understand it, because we are just going to start it right now, and it's going to be amazing. It is something that we are using every day, but we haven't noticed it yet, and we will understand it as we get into this topic. So first, let's understand bridge circuit. See, Wheatstone Bridge is a type of a bridge circuit. We need to know what is a bridge circuit, just like how it connects the circuits and what it does. A bridge circuit can be both AC and DC. It need not be necessarily DC or AC. That's the speciality of bridge circuit. That's great, Amber. It's awesome. But let's get into the topic. And they are used to measure resistance, inductance, capacitance, and impedance. That being said, yeah, of course you can go for magnetism. Yes, Hitesh, we'll discuss that tomorrow as well. You can take up, HCV. HCV is really good. HC Verma is good, but I would recommend, HCV as the second one. First, do complete Resnick Halliday. Amber, do try to look into Resnick Halliday. It's an amazing book. You would love the concepts. You would build your foundation. It will be useful, even not just now, also in your future. And you know what, like most of your concepts will be covered in Resnick and Halliday. For model problems, you can take up some Harian series like DC Pandey. That's what I did. I loved DC Pandey. And there are also, dedicated test series books that you can buy online. You have an Unacademy subscription, you can get on that. You can attend lectures. That should be more than enough, I guess. And like you can also, maybe like do HC Verma after completing these two books. Or like what other lecturers recommend, you can do the HC Verma first, but these concepts will be already covered in Resnick Halliday and DC Pandey, so you need not worry about HC Verma. And HC Verma is a really good book. You want to do it as the second phase thing, and if you have already completed HC Verma, that's well and great. You can proceed into DC Pandey, and on the sideways you can keep reading for you can keep reading the Resnick Halliday. And what was your question? I guess I answered your question. I answered both of your question. That's amazing, Hitesh. Do get onto Unacademy Plus platform and do keep on attending the test. It is very important that you attend the test. It's not just only about taking up the subscription. Go daily to your classes. Don't miss it. If you're over here, well and good. Do attend this lecture. Do come to this lecture every day. Do attend your test. Do your quizzes and get your doubts cleared. See, I'm delivering a class on JEE English channel, which is meant for everyone. It's a public channel on YouTube. We are supposed to deliver lecture for everyone. So do get on to that Unacademy special channel. Do ask your doubts, your specific doubts over there. There are lecturers who are there dedicatedly to clear your doubts. And you should be the first one, Hitesh, to ask any doubts. You can come and attend these lectures. I'll clear all your doubts and base. I'll make your foundation stronger. Now you need to go there and ask your doubts. Do your live quizzes. Do your test, Hitesh. And I hope this helped you. And what about your question? HC Verma of 12th class of electricity. What should I do next? Magnetism from HC Verma or electricity from Irido? No, Amber. If you're preparing for JEE, wait a little time to do the Irido. Okay, it's probably like 0.01 percentile of the people, or 0.1 percentile of the people who are doing Irido. So now you want to complete model problems. HC Verma is not good enough for model problems, to be honest. You need to do the model problems, which is more important for JEE. It's just not that you complete a conceptual book or like conceptual book with little bit model problems, you need to completely skim through the JEE syllabus first. You need to complete those questions of different difficulty levels. Iradao is going to be tough, more than tougher. I've solved Iradao. Iradao is amazing, means amazing. Many concepts will become clear, but that may be the last book that you want to do right now. And good evening, Jaran Joel. Nice to have you. And Hitesh, previous year paper, we will discuss that tomorrow. Anyway, but previous year paper, you may want to do it every now and then. You shouldn't be dependent on previous year paper. Don't expect anything from previous year paper in IIT JEE Advanced or IIT JEE Mains. Probably in JEE Mains, you can expect a little bit of model problems. Don't expect anything in JEE Advanced. And Amber, Hitesh, Jaran, be regular to the classes. And what I can see from all your queries is that you are preparing already for JEE Advanced. And do stick to your schedule. We'll discuss about it tomorrow as well on the special class and the special class that will be happening. Okay, do keep yourself updated on it. And guys, I guess now let's get into the topic. Maybe we can get into the discussion later, but I guess it was amazing that you guys asked me about the books. And let me repeat it again. You may want to do DC Pandey, H.C. Verma and Resnick Halliday for the concepts. They explained it the most amazing way they can. And DC Pandey, they have all the model problems that you need to do. Especially during my time, I did nothing, just DC Pandey for last like 2 to 3 months, and read Resnick Halliday. That's all. And if you have any queries about other JEE books, you can ask the other lecturers as well. And Akhil, yes, I guess so. If you build your foundation, but I would recommend taking up like a goal on NEET, maybe on Unacademy, and you want to prepare for JEE Physics. But do attend these lectures. They will give you, if you're also preparing for engineering, you may want to definitely attend this channel every day. And I hope this clears your doubt as well. Yes, NEET is nothing. It's going to be like a little bit less advanced than JEE Mains or JEE Advanced, or maybe somewhere matchable around JEE Mains. So once you are accustomed to it, you can do that. But do remember, for NEET, you need to practice around those kind of problems, like what is going to be asked in the exam or whatever it is, because every exam has its own pattern. Like BITSAT has its own pattern, like Manipal entrance has its own pattern. Even ISRO exams have their own pattern. So ISRO is going to be like, you have to do IRIDA to get into like ISRO based academies or something like that. In JEE, you have to be fundamentally be very strong. You need to have that aptitude, and then you can crack JEE very easily. And JEE is very easy. Physics is very easy. Do keep that in mind. You can do everything. And that's amazing, Hitesh. That's amazing. Yes, absolutely. Yeah, let's get into the topic of the day. That is going to be Wheatstone Bridge. We need to complete this topic today, and this topic is one of those amazing topics, and we won't get this time again, because in this lecture we are going to talk something also very technical, not just about JEE syllabus. So it's going to be interesting, guys. Stay along and do enjoy this video right now. We can discuss it later. Okay, now getting into what is bridge circuit. Bridge circuits can be both DC and AC. They are a specific kind of circuits which are used to measure physical quantities. They are basically used to measure physical quantities based on resistance, inductance and capacitance. Impedance is nothing but it's dependent upon resistance, inductance and capacitance. Okay, and they are used as an like these resistors, these components are used to measure some real life properties, or like real life parameters, temperature, sometimes pressure, whatever it is. The circuit is designed in such a way, and the beauty of any bridge circuit is it operates on null indication principle. What do I mean by null indication principle? Null indication principle means it is independent of the characteristics, or the indication is independent of the calibration. Isn't it amazing? If I don't require to calibrate it every now and then the device can deliver high accuracy. In fact, bridge circuits are used for very high accuracy measurements. They deliver like very accurate results compared to many of the normal circuits. And this bridge circuit is they are making use of similar components to make it happen. And remember, bridge circuits can be both DC and AC. There can be like inductance, capacitance, impedance, anything on them. They involve null indication operation, which means the characteristics is independent of the calibration, and also the characteristics, I mean like the measurement is independent of the characteristics, and the like the other kind of calibration requirements. That means if someone asks you, why do we use Wheatstone Bridge over other kind of circuit? Let's say you have a conceptual question in one of your exams. Because you are using it, it is more accurate. I mean, it is more accurate, that is why you are using it. I hope you got this point, and they deliver very accurate results. Okay. And generally it can be a resistive or capacitive component, and one that component would be used to measure physical parameters like what we discussed. It can be temperature, pressures, etc, 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 that you try to measure some real life thing. Absolutely, I told you at the beginning itself, current and electricity is very practical, just like other topics in physics. Physics is in fact very practical, and current and electricity is super practical. It's something that you're seeing every day in your mobile phones, etc, etc, and you need that. Okay, you need to understand the working, and you will be able to develop amazing things in your life. And that being said, like, there are two categories that we talked about. One is DC bridge, and the other one is AC bridge. Generally under DC bridge you have Wheatstone bridge and Kelvin bridge. Okay, there are two kind of bridges in DC bridge. One is Wheatstone bridge and Kelvin bridge. And what kind of bridges? Wheatstone bridge, a DC bridge. AC bridges, there are like numerous kind of AC bridges: similar angle, dissimilar angle, Maxwell bridge, radio frequency bridge. There are like n number of AC kind of bridges. Even in DC there are many kind, but these are the most used ones that are going to be generally taught in your like JEE or maybe even your advanced classes. So it's going to be Wheatstone bridge is a DC bridge. That being said, why Wheatstone bridge? Like, why do we use it? We use it just like any other bridge circuit to measure some physical quantity, and we generally try to make use of resistance to do it. And what all does a Wheatstone bridge circuit consist of? Talking practically, not from just the circuit point of view or not from just the examination point of view, Wheatstone bridge has like many important components in them. One is going to be the voltage source, the other one is going to be galvanometer. Okay, and this galvanometer, as you see, would connect and measure the electrical results between the two parallel branches containing 4 resistors. Okay, there are 4 resistors in Wheatstone bridge. Okay, there are 4 resistors in Wheatstone bridge. Okay, this is kept as a variable resistor. We will talk about it, why it is kept as a variable resistor. And there are 4 resistors, and there is a galvanometer connected between D and B, if you noticed. And where is it connected? Where is this galvanometer connected? It is connected between this and this parallel combination. Okay, it is connected between the parallel combination of the two resistors, and in total a Wheatstone bridge generally has 4 resistors, and a galvanometer is used to measure the electrical properties, and there is a voltage source. These are the 6 components or major 6 components of Wheatstone bridge. That being said, how can I confidently tell you that a balanced Wheatstone bridge works, or how do we use this or exploit this Wheatstone bridge? Do we have any proof? People often keep on saying that okay, it works that way, but how do I infer that? We are going to prove it today to you using Kirchhoff's law. You can do it even using Thevenin's, but today we are going to make use of Kirchhoff's law to understand it. If you have a look at the circuit, here a voltage source is connected. Okay, just do remember that was an example circuit. This is the circuit that we are going to analyze today. It has a voltage source EI, and there is another like voltmeter, you can call it voltmeter or some voltage source. We are going to take it as another voltage source that is going to measure potential between this node, this connection and this connection. And this connection and this connection is in parallel. This connection R2, R4 and R1, R3. Combination of R1, R3 and R2, R4. Just a moment. Yes, they are in parallel. I mean this connection. Current would flow in this way. Okay. Now it would get divided in this way. So this connection, I'm sorry guys, this would be in parallel. This two would be in parallel. Okay. I'm correcting myself. Do carefully observe these points when I'm correcting myself. That means something has gone wrong. So these two and these two are in parallel. Okay, R3, R4, I mean in series. I'm really very sorry. R1 and R3 are in parallel. R3 and R4 are in series. Similarly, R1 and R2 are in series. R1 and R2 are in series, and R3 and R4 are in series. And these combination of R3 and R4 is in parallel with R1 and R2. Okay, that means thinking logically, thinking without using any Kirchhoff law, the current I1 should be equal to current I2. Okay, it enters this node, there is no way for it to escape. Assume this voltage source is where the current cannot flow, and then you get back over here and this has to return, the current has to return. So I1 should be equal to I2, and similarly I3 should be equal to I4. Okay, agree? Easy? Pretty easy. Until now everything was easy. Now let's make use of Kirchhoff law to solve this problem. Until now we understood that there is a voltage source EI in this case, okay, which connects R1, R2, R3, R4. R1 and R2 are in series, and R3 and R4 are in series, and these series combination of R3 and R4 and R1 and R2 are in parallel. That being said, we will work around Kirchhoff law to prove how voltage source, I mean like Wheatstone bridge works, and especially how this balanced Wheatstone bridge is used in our commercial and practical applications. Okay, first I'll take up a loop. It's a loop analysis, right? Kirchhoff law, we are doing a loop analysis to make sure, you know, the voltage, that the net voltage that when you take, you know, like a circle and you know, inside that loop should be 0. That means EI minus of I1 R1 minus I2 R2, since the current is in the direction of the loop, minus of I1 R1 minus of I2 R2 is equal to 0, which tells you EI is equal to I1 R1 plus I2 R2. Okay, simple, understood, easy, pretty damn easy I guess. Then now what will we do is we should keep on applying such Kirchhoff's law, finding all the loops. If you carefully notice, there are anywhere around 4 loops that we can analyze. Okay, we are going to make use of 4 different loop analysis to understand Wheatstone bridge, because Wheatstone bridge is not just that R1 R2 is equal to R3 by R4, because that's balanced Wheatstone bridge. We are talking about the bridge circuit Wheatstone bridge. And that being said, what about the next kind of loop? The loop on the bottom. Let's call this green loop. And in this green loop, again if you notice, EI minus I3 R3 minus I4 R4 is equal to 0, which tells you nothing but EI is equal to I3 R3 plus I4 R4. Isn't it, students? This is the essence of the second loop. What about the third loop? What is the third kind of loop? There is another loop if you have noticed, and there are actually another 2 such loops that if you have noticed, this is also a loop. Okay, now let's say I haven't, you know, connected any voltage source over here, or even if I connected a voltage source over here, so we can still apply Kirchhoff law. But let's say if I connected a voltage source over here, E0. Okay, assume this to be that voltage source or that voltmeter using which you are measuring the potential. There is some, assume there is a, you know, like a voltage applied to it. That being said, now let's call this blue loop. How would this loop look like? This loop would look like, since I2 and I4 are in the opposite direction, there would be a sign change. So it would be E0 minus I4 R4 plus of I2 R2 is equal to 0. Okay, that would give me E0 is equal to I4 R4 minus I2 R2. When it moves to the RHS from LHS, it would give me E0 is equal to I4 R4 and I2 R2. And students, have you identified the 4th loop? Which is the 4th loop we are talking about today to solve the problem? We have already got 2 equations for EI. There should be another such equation for E0. Okay. Now, what is that another such loop? Isn't it a loop? Isn't this one a loop? If you notice it, this is also a loop. And I'm going to call this loop as orange loop. Okay. This orange loop as, you know, if you work around the same Kirchhoff law, closed loop law, and then you would understand that E0 plus I3 R3 minus I1 R1. So See, I3 R3 is the opposite direction to the loop analysis. So it's going to be E naught plus I3 R3 minus I1 R1 is equal to 0, which would give me E naught is equal to minus I3 R3. Once it moves on the LHS, it will give me minus I3 R3 plus I1 R1. So now we have 4 equations around these 4 colored loops. We discussed about 4 colored loops, and these 4 colored loops have 4 equations that we are going to deal with today to understand Wheatstone Bridge and also to solve any problem around Wheatstone Bridge. Okay. First one, red loop. The second one, green loop. The third one, blue loop. And the fourth one, the orange loop. These colorful loops would give me these different equations that we just discussed. EI is equal to I1 R1, EI is equal to I3 R, EI is equal to I1 R1 plus I2 R2, EI is equal to I3 R3 plus I4 R4, and the blue loop would give me E naught is equal to I4 R4 minus I2 R2. And similarly, orange loop I have I minus I3 R3 plus I1 R1 is equal to E naught. One way is that I can directly claim, just like how we did in the beginning. I told you this current, since this current and this resistor is in series, I3 should be equal to I4. Okay, we are calling it the bottom node. What about the top node? The top connection, the current flowing on the top, I1 is equal to I2. Okay, these two currents are equal. Okay, I hope everything is clear until now. Now you have solved the Wheatstone Bridge. Now what are you going to do? You are going to try and express EI in terms of E naught or E naught in terms of EI. But what we are going to do is we are going to basically eliminate I1, I2, I3, I4 and like this current. If you eliminate the current, we will get the voltages. The voltages EI and E naught in terms of resistors or resistances value. If I eliminate all of these value, I have 4 equations, and I know also that I1 is equal to I2 and I3 is equal to I4, which I can substitute and eliminate this I1, I2, I3, I4 using this 4 equation and express EI or E naught in terms of each other. Okay, we are basically going to express E naught in terms of EI. We'll understand why. Now that being said, we can use this loop equations to express everything, that is E naught in terms of EI, which is going to be EI is equal to, E naught is equal to EI into R1 by R1 plus R2 minus of R3 by R3 plus R4. What did you get over here? The Wheatstone Bridge equation. This is called the Wheatstone Bridge equation. E naught is equal to EI into R1 by R1 plus R2. Okay, addition of R1 and R2. If you can easily remember, that's the easiest way to do it. Think about it, R1 plus R2. Okay, and then you also got R3 by R3 plus R4. Now that being said, if I told you E naught is 0, that means if the voltage across this nodes, the voltage across these nodes are 0, that means it's a balanced Wheatstone bridge, the one that you have been reading forever. Okay, easy. If I make this E naught 0, it's a balanced Wheatstone bridge. What do I mean by balanced Wheatstone bridge? What is this equation going to be useful for? Balanced Wheatstone bridge is where we are going to play around. Since we know this E naught should be 0, using this we will develop applications, electronic applications, products, etc., etc., and etc. So in this case, if you equate E naught is equal to 0, you can also just get this equation. If this is 0, if this thing is nothing but 0, You can basically take EI on the other side and cancel it out. And if you had carefully noticed, you will get this kind of equation. R1 by R1 plus R2 is equal to R3 by R3 plus R4. And what if I can say that R1 by R2 is equal to R3 by R4? Can I say this? If you take the equation on the other side and if you take this equation on the other side, then you will solve it to get the same one, the same usual thing that you used to look at your books. If I take this, if you take this and if you take this on the other side, you will get the same equation. Or else, the simpler way of doing it is, you can just take this on the numerator. You can take the inverse. So if this is true, that is R1 by R1 plus R2 is equal to R3 by R3 plus R4. Can I say R1 plus R2 by R1 is equal to R3 plus R4 by R3? Okay. Now, on the left hand side, what am I going to do is, I am going to really divide it. That means I will get 1 plus R1 by R2 is equal to 1 plus R4 by R3. I'll cancel out the 1 on each of the sides and then I'll get it in the form of R2 by R1 is equal to R4 by R3. Again I can take the inverse and write it as R1 by R2 is equal to R3 by R4. And the point you have to understand over here is how we solve the problem, what is the potential difference between them. So these are equipotential nodes or equipotential connections. If you even connect a resistor over here, there isn't any current that is going to flow through them. You keep it as open circuit, or if you connect a resistor over here, there should not be any current that should be flowing through the circuit. Quite easy, pretty damn easy. Now, let's talk about the application of Wheatstone Bridge. Wheatstone Bridge. We have been studying Wheatstone Bridge forever. But what is the real application of Wheatstone Bridge? How and why? This topic was about how does the Wheatstone Bridge work and why do we really need the Wheatstone Bridge. We study it every day, we solve it in our like JEE Mains, JEE Advanced. Many of your exams, NEET, etc. has a Wheatstone Bridge based questions many times. But why do we study it? Is it really important? Basically some, like just scientists made it, should we study that? Absolutely no. This Wheatstone Bridge has many applications and how we are going to use the Wheatstone Bridge is the key to the concept. See, if I have a balanced Wheatstone Bridge, let's say where R1 by R2 is equal to R3 by R4. Okay, this one satisfies. This one, if this one is satisfied, or if you design the Wheatstone Bridge in this way, if I even change a little bit of any resistor over here, okay, let's say I'm changing R2 by some amount. In that case, can I say that this entire Wheatstone Bridge is collapsed? The balanced Wheatstone Bridge is collapsed? If I change the resistor a little bit, the entire Wheatstone Bridge changes. And if I kept equal values, R1 is equal to R, R2 is equal to R, R3 is equal to R, R4 is equal to R, I was supposed to get 1 is equal to 1. And suddenly I don't get that because one of the values is changed. And I also start observing a voltage or a current flow across E0. Now the value of E0 is not 0. The resistor has changed a bit, a little bit, okay, a little bit. Now you observe that the balanced Wheatstone Bridge no longer exists and you can calibrate the values. What do I mean by the calibrate the values? You are not going to calibrate the Wheatstone Bridge. You are going to calibrate the measurements and make sure you get some application. One of those famous applications was strain gauge. Think about it. If I apply a strain on some metal, that strain is going to create some delta, R change in resistance. Length is going to change because I'm applying strain. There is a delta L. That strain is going to change the value of resistance, and using that I can measure the strain. Hence it is used in strain gauge. There are many such applications of Wheatstone Bridge. You can keep reading about them. And then See, R3, R2 is equal to not R3 is equal to R4. That's wrong, Alicia. So talking about that, we are basically taking the ratios. We are trying to create an equipotential point. So what we are trying to do is, we are trying to create the equipotential points. And now the equipotential points here need not necessarily have R1 is equal to R3 is equal to R4. During that application, if I understand you correctly, what you are trying to ask me, you are asking why are you making R1 is equal to R2 is equal to R3 is equal to R4 in the application. I hope that's your question. Okay, I'm assuming this is clear to you. How did we get this and what is the thing? Yeah. Now, why did we make all this R as equal? Just for the sake of simplicity or convenience, nothing else. You can work around anyway. The issue is basically whenever you try to design a resistors, the resistors really do not have the same value. If you try to use R and R, there are high chances that you may get any nearby value. Okay, that's the reason they are using R. In fact, if you can achieve that ratio R1 by R2 is equal to R3 by R4, then you can do that. There is no issue in it. There they generally try to just divide that resistor itself using some combination and try to use them. Okay, generally they try to use same kind of resistors, but that is just for convenience, and it is also based on the fact that it is generally impossible to design two chips or circuits or any resistor of the same value, exact same value. So that becomes very complicated, so they try to use same resistor or try to take a resistor of the same material and make it. Okay, I hope you understood. I hope you loved Wheatstone Bridge concept. It's an amazing concept. If you understood it, do share this video with your friends, do share this video with your family, do share this video with any science or non-science enthusiastic. We will make sure that they get enthusiastic about physics, and do share it, do share this knowledge and make them enlightened, make sure they get every knowledge that is required to understand the practical life. And guys, keep smiling students. It's very important that you keep smiling. Tomorrow we have a special class. Do come to the special class, and success you have to achieve it. And in this case of current electricity, you don't have to perspire much. You can just achieve it attending lectures and working around a little bit of problems. And do share this channel with the people you love on the social media, on every social media possible. It's a scientific lecture that everyone needs to understand and love. Do it, and do also share the other video. If you missed the earlier video where we have discussed like a 20-30 minutes video on which we have discussed how to crack JEE Mains in less than 30 days. That's what we discussed earlier in the video. And guys, do also share that video. Do have a look at that video. It's a very interesting video. I've given you a robust strategy to do that, a very robust strategy to crack JEE in less than 30 days. That means if you're preparing for this September month, you can make use of that plan. Do follow that plan and make sure that you're able to do it. We also have a special class tomorrow, the Saturday, that is from 4 to 6 p.m. and on how to score 99 percentile and above in JEE Physics. Guys, do keep do stay on our JEE English channel. We'll keep you updated about the class, and this is going to be amazing. In this we are going to discuss how to score 99 percentile in JEE Physics, maybe also for your advanced. And this is from Unacademy and JEE English, that is Unacademy JEE English. And how to attend such special live classes, you may want to download the Unacademy learning app, and we have several such like special classes going on for free of cost, and you want to download this app, and it's an awesome resource for your education, for your learning, for your hustling around sciences and physics. And guys, do keep loving physics. Do not forget to love physics. And if you are preparing for exam, and if you are preparing rapidly for the next 1 month, you may want to get onto this Unacademy subscription. You may want to purchase this Unacademy subscription and choose your goal as IIT JEE. Do not forget to do that. Just don't buy any package that you want. Do buy IIT JEE, and you can choose your program accordingly. I believe many students over here are also like 9th class, 10th class, 11th class. So do choose it accordingly and make use of my coupon Murli Live to get a 10% instant discount. And guys, I'll come to know that you have applied my coupon. And awesome guys, take care, stay safe, bye bye. And before that, do download this Telegram app and click on this link or get onto this JEE_English to do some amazing, to get some amazing updates on our channel. Also click like and subscribe on this video and click on that bell notification to get timely updates. It's also necessary that you click on the bell notification to get timely updates, guys. It is very, very important to do that. And do enjoy your life, do enjoy physics, do love science, do love physics. and keep spreading the knowledge. Share the video, share every such video on our channel with your friends, family, and everyone who wants to love and learn science and physics. And guys, do definitely have a look at the video if you're preparing for JEE, or even if not, what would be that unique strategy that you have to apply to crack JEE Physics within next 30 days. It is quite possible, students. You need to give the time and it will happen on its own. And do love physics. Physics will love you back. Take care. Stay safe. Bye bye, students. See you in the next class.